Okay, so this PowerPoint is all about the periodic table of elements and looking at the different groups that we see on there. So our periodic table of elements looks something like that. Now, as a reminder, what are elements? The elements alone or in combination make up our bodies, our world, our sun, and in fact the entire universe. So really elements make up everything. And that's really why it's so important to understand how they differ from one another. When we look at the Earth, the most abundant element in the Earth's crust is oxygen. Hydrogen actually has a really small amount. It's oxygen, and then silicon actually is our next highest one. Elements in the periodic table are in columns, okay? And we call these columns groups. Okay, so you're going to color your periodic table like this to show the different groups. Elements in the same group have different properties, okay, and there are many reasons for this, and we'll talk about that. But part of the way that the periodic table is organized has to do with the elements being in the same group or the same column having similar properties. When we change to our horizontal rows, then those rows are called periods, and they do not have similar properties. So they are not similar to one another. They just happen to be in the same row. The groups, then, we have names for these different groups. The first group we're going to look at is hydrogen. Hydrogen is actually just one element, but it is in its own group because it has special properties all on its own. The hydrogen square sits atop family A1 or group A1, but it's not a member of that group. The hydrogen is in a class all of its own. It's a gas at room temperature. It has one proton and one electron, and it only has one energy level. Hydrogen only needs 2 electrons to fill its valence shell. Now, a valence shell is that whatever the outermost ring of electrons are. So it only needs 2. Okay, if we're thinking back to Bohr diagrams, when we drew a hydrogen, it would only have the one ring, and that first ring can only hold 2 electrons, which is where that 2 comes from. The alkali metals then are right below that. The alkali group is found in the first column of the periodic table. The atoms of the alkali metals have a single electron in their outermost level. In other words, they have one outer electron. They tend to be shiny, have a consistency of clay, and can easily be cut with a knife. Okay, now some of these elements like sodium have these properties when they're all by themselves, but when we tend to think of sodium like sodium chloride in salt, that's a compound. It's not the straight sodium element. So we're not looking at something like salt as being indicative of an alkali metal. Alkali metals are the most reactive metals. When they touch water, they react violently. They tend to explode and ignite. Alkali metals are never found as free elements in nature. They are always bonded with another element. Okay, so the only way to get them free and by themselves is to undergo some sort of chemical process. I mentioned that they are the most reactive. What does that actually mean? We will be describing elements according to their reactivity. Elements that are reactive bond easily with other elements to make compounds. Some elements are only found in nature bonded with other elements. So what makes an element reactive? An incomplete outer electron level. All elements except hydrogen, lithium, beryllium, and boron want to have 8 electrons in their outermost energy level. This is called the octet rule. Okay, so all elements want to have 8 in their outer level except for those few. Atoms bond until that level is complete. So atoms with few outer electrons lose them during bonding. Atoms with 6, 7, or 8 valence electrons gain them during bonding. So remember back when we talked about ions, that's how those things become ions and how we can determine what the charge on that is. If you are confused about this, make sure you talk to your teacher about going over it, okay? We will get more in depth on reactivity and bonding because this formation of charges has to do with bonding in later units in the matter learning targets. So the alkaline earth metals, these are the next group over, so the second column. They are never found uncombined in nature. They have 2 outer electrons, and the alkaline earth metals include magnesium and calcium among some other things. The transition metals then are that middle block. Okay, the whole middle block here are called transition metals. Transition element includes elements in the B families. Okay, so we call these B families. You don't need to worry about that. These are the metals you are probably most familiar with, things like copper, tin, zinc, iron, nickel, gold, and silver. These are the things we think of when we think of metals. They are good conductors of heat and electricity, again, because of the way that they bond. And you don't need to worry about that because piece. Just know that they are good conductors of heat and electricity. Compounds of transition metals are usually brightly colored and are often used to color paints. Transition metals elements have 1 or 2 outer electrons, which they lose when they form bonds with other atoms. Some transition elements can lose electrons in their next to most outer level. Okay, again, not something super important for you to know right now. Just know that they can have varied charges. So the other ones have a set charge that they're going to take on. The transition elements can have varied charges. Transition elements have properties similar to one another and to other metals, but their properties do not fit into those of any other category or any other group or family. Many transition metals combine chemically with oxygen to form chemicals called oxides. The rare earth metals then are the ones down there on the bottom, okay? And these are ones that we won't even get into really studying besides this slide. The 30 rare earth metals are composed of the lanthanide and actinide series. One element of the lanthanide series and most of the elements in the actinide series are called transuranium, which means that they are synthetic or man-made. So they can't even be found naturally on Earth. The next family you're going to worry about is this one over here. It's called the halogens. It's our second to last column. The elements in this family are fluorine, chlorine, bromine, iodine, and astatine. Halogens have 7 outer electrons, which explains why they're the most active nonmetals. They are never found free in nature, so they always have to be bonded with something. Halogen atoms only need to gain 1 electron to fill their outermost energy level. If you notice, we said that all elements, back a few slides, we said all elements want to have 8. These guys have 7, so if they gain 1, they're up to 8. They react with alkaline metals to form salts. So notice chlorine was one of these elements, these halogens. One of the alkaline metals was sodium. So sodium chloride is what we think of as table salt that we eat. The noble gases then are the very last column here. Noble gases are colorless gases that are extremely unreactive. One important property of noble gases is their inactivity. They are inactive because their outermost energy level is full. Because they do not readily combine with other elements to form compounds, the noble gases are called inert. That means that they don't bond with other things. The family of noble gases includes helium, neon, argon, krypton, xenon, and radon. All noble gases are found in small amounts in the Earth's atmosphere. If you have any questions about the groups or the groups on the periodic table, families, remember, is just another word for groups. The word we want you to use, though, is groups. If you have any questions about the groups on the periodic table, maybe watch this video again, chat with your teacher, let someone know, and we can help clear that up for you. Make sure you review your notes at a later time and do the summary and Costa's questions if you so choose.